Solve this today's LeetCode problem. This is LeetCode medium, magnetic force between two balls, right? So in this question, let's see, the question is asking that Rick discovered a special form of magnetic force between two balls if they are put in his new invented basket. Rick has an empty basket. The ith basket is put at position I. Morty has m balls and needs to distribute the balls into the basket such that the minimum magnetic force between any two balls is maximum. This line seems to be confusing, but we will understand this line, right? So, Rick stated that magnetic force between two different balls at position x and y is mod x minus 1, right? Basically, difference between the positions of this basket, right? Position, right? So, given in the integer position and the integer m, return the required force. So basically, we need to uh, put this m balls into the baskets which are at the positions which is given in the position array. Right. Basically, we need to put this m balls into these baskets. But the question is asking that we need a required force. We need to put these balls in the baskets as how that we will get the minimum magnetic force between any two balls, which will be maximum. What does it means? Let's understand this meaning. See, the question is asking about minimum magnetic force between any two balls, right? This you will understand this line, right? Minimum magnetic force between any two balls, which will be maximum. This is the meaning, right? We will just add some words which will be maximum. What does it mean? What does it mean? It means that the balls which we put in the basket at any because there can be many possibilities, right? If I take this, these three balls can be placed at one, two, and third position. Can you place at one, two, and fourth position? Can you place at one, two, and seventh position? Can you place at one, three, four position? Can you place at one, three, seven positions? Right. There are many possibilities for placing it. Right. One, four, seven position. Right. One. Uh, right, 147 position. So there are many possibilities to put these three balls. So we need to put these balls at at some place where, if I choose this, suppose if I choose this, right, if I choose this, the minimum magnetic force between any two balls is what will the minimum magnetic force between any two balls between 1 and 2 1, 3 to 1, and 1 and 3 is 2, right? So minimum, what will the minimum of 1 1 and 2 is 1, of course, right? What will the minimum magnetic force between these 1 to 4? This will be 1, this will be 2, and this will be 3. Between 1 and 2 1, 2 between 2 and 4 is 2, between 1 and 4 is 3. What will the minimum of this? 1, right? The same thing here, between 1 and 2 1, between 2 and 7 is 5, and between 1 and 7 is 6. So what will the minimum? 1 again, right? And if you we will do this same for every possibilities. 1 and 3 2, 3 and 4 1, 1 and 4 3, right? So that will be 1 again, right? So if we do this, and what we need to do, we need to take the maximum of all the minimum, the maximum of all the minimum again, the maximum of all the minimum. These are the minimum which I get for individuals, from individuals. And between these minimums I need to find the maximum, and the maximum which will be the position, that would be our answer, definitely, right? Understood. So this 1 and 3 is 2, 3 and 7 is 4, and 7 1 is 6. So that would be 2. Now the final is here, 1 and 4 3, 4 and 7 3, and this is 6. So that would be 3. So if you see, between all of this, 1 1 1 2 3, what is the maximum? 3, right? What is the maximum? 3. And which is the minimum of 147? So basically we need to find the minimum magnetic force between any two balls, which will be maximum. That is the meaning of this question. I think now you have understood the meaning of this question, right? So basically, we need to find the minimum for each positions, uh, each possibilities, and among that minimums force, we need to find the maximum force, and that will be my answer. So it means this answer. It means I have a answer. My answer will be 3. It means this 3 is the force which will be the minimum magnetic force, which is maximum, right? That's the answer. That's the required force, right? I think you understood the problem, right? Now, let's see the constraints here. If we see the constraints here, n is 10 to the power 5, position I is can go to 10 to the power 9, and yeah, all integers position are distinct, and this is position not length. Okay, fine. So basically, we need to find the required force, right? And we have given some positions, and we need to put balls in positions. So let's analyze the question. We need to put balls in the positions, or in the buckets, which is placed at which is placed at positions, right? Which is placed at positions array, right? So this is 1 2 3 4 5 4 7, and we have 3 to 5 buckets and 3 balls, right? So, and there is no constraints on given on n and m values, right? So m can also be greater than this n, right? In that case, we can't place uh, we can't place the balls in buckets, right? That's the case. That can be also possible. But yeah, this is given that m should be less than position dot length. It means I can place all the balls in my length, so that wouldn't be any cases, right? So we need to push all the buckets which is placed at positions are definitely for sure, right? Now I need to focus on this force again. I need to focus on this force, that I need to calculate force somehow. So how will I calculate force? So basically, if you see the maximum force, the minimum force, what can I get? The force, the range. What would be the range of the force mainly? What would be the range of the force? Basically, the range of the force can go to from 1 to max value of positions array, right? Max value of positions array, max value of position, right? In the array, that can be the range of force, right? So I'm sure about that the answer would be between in these only. Answer would be between these only. But one thing you see, that the force, the magnetic force between two balls is at the position xy, that would be x minus y. It means that would be max value of position in array minus 1, right? I'm sure about that the force will be between 1 to this only, right? Because all the positions are distinct, it means the minimum force would be 1, and the maximum position would be a maximum force would be max value of position in array minus 1, right? I'm sure about that the answer will be between these only, right? Okay, we have a range of forces, and we know that answer would be lie in this only. So let's suppose we started from the position, any position, right? We will what we will do, we will take any force, so one thing can we can do that we can start from 1 to this max value, right? And check for each force check for each force, that which force can give us give us can put these balls put these balls put these balls in our bucket, right? And the maximum force which I can put all these m balls in bucket, that the maximum value of the force would be my answer, because ultimately I need to find the maximum force now. Ultimately I need to find the maximum force. So suppose I take, so how we will confirm that? So suppose I take this example only, this example I take this example. So if you have solved previous question or yesterday's question, if you have solved yesterday's question, that was similar type of question, similar type of question that was similar type of question. But here the slightest modification would be there. But here the slightest modification would be there. If you have solved previous question, you must attempt this question, right? Would be there, right? Just think of the previous problem and solve this right now, if you have solved it correctly yesterday, right? So the position is m3, and let's take the force value. The expected force value would be, let's take as a 2, right? Let's take it as 2, because the answer can be lies between the 1 and between this 7 minus 1, which is 6, right? Which is 6. It's 6, which is 7 minus 1. The last position, maximum position, minus 1. This can be the answer. But I take a force 2, right? I take force 2. So if I take 2, at which positions these balls can be placed where the force is 2? I'm stating that the force 2 is the minimum force for this, for now, for these positions. So if I take 2, I can place one balls at one position, so I place that, right? For making force 2 between two balls, where would I place this 2? So I want to place this 2 at some position where the difference between the two boss positions would be greater than this force, definitely, because this is the minimum force I want. So 1 plus 2, this 1 plus 2 is 3. So where this position is 3, we got here 3 position. So the minimum position where I can put the second ball would be at 3, not 2, because if I 2 minus 1 is 1 only, and we required minimum force of 2, right? We required a minimum force of 2. So 1 plus 2 is 3. Now again I want the third ball, so that would be at fifth position. But if you see here, we haven't a fifth position, but we got a seventh position. So it means the minimum position is required is 5. But if it is not there, I will be placed at the next higher position, that would be 7, right? So it means, does it mean? This is 137. It means at force 2, I can place all my three balls. I can place all my three balls. It means if I can place at force 2, I will need to check further for higher forces, because we need the maximum value, right? And this is the second value, so I will check for next values also. So now I will check for third value also, right? And now I will check for third value also. So when I check third value, this is one position. 1 plus 3 is fourth position. So 4 is there. So I will place it 4. 4 plus 3 is 7. So I will place it 4. So it means 4 is equals to 3 can also be answered. And this force 2, and between this force 2 and force 3, I will take force 3 if I have choices between this 2 and this 3. So I will take 3, because that is the maximum value, right? Now I will check also for 4, right? And now I will check for 4 also. If I check for 4, the first ball is at position 1, the second ball would be at 5, but don't have 5, so next greater value is 7. So we will place that. But now the thing is, the third position should be at 11, should be at 11. 7 plus 4 is 11, but we don't have the position. So it means I can place only two balls there. It means this fourth position cannot be our answer. And I'm assured that if I'm assured of that if if I cannot place all the balls, I cannot place all the balls at force 4, at minimum force 4, mean force 4. It means I can't also place all the balls greater than this, greater than 4 values, greater than 4, greater than 4, right? I cannot place all the balls greater than 4. If I can't place at 4, do you think really that I can place at 5, 6, or 7? No, I will don't check later on these things. I will check only. So the possible answers are 2, 3, and also 1, because 1 plus 1 is 2, and 1, if I take minimum force 1, then I can also place these three balls. So the possibilities are 1, 2, and 3. So we need to take the maximum value, which is 3. So if you see here, what we are doing, we are checking each and every force. We are checking each and every force from 1 to the max value of positions in array minus 1. But if you see the constants here, the position I can go to 10 to the power 9. So if you want to check like that, you need to iterate till 1 in 9 minimum. Minimum 1 in 9, right? For each and every force is 1 in 9 into the length of this position array to check that. that would be can go to n, right? So that is the huge, that will definitely give you TLE. So the same thing happening yesterday's problem, right? Same thing was happening yesterday's problem. So in that case, what we have done, so basically I'm assured of that I'm sure of that, that I need to check the forces, and then can only find that find then I can only find the required force required force, right? So basically, what will I do? I will check. I will check. I will simply apply binary search on forces. So basically, when you need to apply binary search. So basically, when this type of problem, the minimum magnetic force of the any two balls is maximum. This type of problems, mostly it required binary search, right? If you see this type of problems, you must think of binary search. You must think of you better think of binary search, because this type of problems mainly solved by binary search, right? So if you see this type of problem, that you need to apply some forces, and the range is too long, so you must apply binary search, because the binary search takes log of time. This 1 in 9, you don't need to do this. If you apply binary search on this force, this will be required only 1 in 9, because you don't need to apply for each and you don't need to check each for each and every force. You will just require some logic to reduce the space search. The previous space search was 1 in 9, can go to maximum value. This is the maximum position which is given, right? This is the maximum position. So the the maximum space search is space search space sorry search space is 1 to the max positions add a minus 1, right? Right, this is the search space. Now, how we will reduce this search space? So basically, if you see here, one thing I told you, that if at some position if at some position, if I am not able to put all the balls, I don't need to check for later on forces. In this case, if I not able to put all the m balls in our bucket positions, so do I need to check for 5 6 7 and all after this 4? No, it means I have reduced all the search spaces, right? I have reduced all the search spaces, right? So basically, what we are doing, so if I take the same example as this, if I take the same example as this example, if I take the same example, so the maximum the search space is here is 6, right? So the lower value is 1, the lower value is 1, and the previous same format, and the high value is 6, right? But the slightest twist is here, that here we need to find maximum, and yesterday's problems I need to find minimum. It means if I got some answer that this can be the possible answers, it means I need to check for next greater elements, because here I need to find maximum, and previously it was find to minimum. I will show you that what I mean. So basically, what I need to do, I need to find a minimum, a mid value. So this its mid value would be 6 plus 7 by 2, which is 3. So at three positions, at third position, it means the the expected force would be, this is the force, this representing this representing force this is also representing force. So we will check on this force value, that whether at this force value I can place all the balls at a position. So this mid is 3, and I have shown you at position 3, what is the position 1 4 and 7, it's the position. So I can place this, I can place all the m balls at a specific position, right? A specific position. It means what does it mean? It means if I can place all the m balls, it means three fourths, the mid value can be our answer. Mid value can be, maybe our answer, maybe our answer. but I need to check for further because I need to find maximum value now. I need to find the maximum value. So but I will but I will but I will check but I will check for further for increased forces also, right? Because we don't know now that at increased forces it can also happen that mid is equals to 4 or 5 or 6 or 7, we can place all the amboss, right? So what we'll do to increase our forces, what we will what do you think that what will change, this low or high, what will change? Low would be change. So low would becomes mid plus 1. If I increases mid plus 1 for, so basically when we when we increase our low, when we have when we have balls, when we have placed all the m balls or greater than m balls, right? When we have placed all the m balls uh, at the specific positions, then I increase my low value, right? So low becomes mid plus 1, it means it becomes 4, right? Now this 4 plus 6 10, and that would be 5, right? Now at position 5, what will I check? I will check that whether we can place it or not. So the first position would be 1. 1 plus 5 is 6. 6 is not there, so we will take the 7. So 7, right? Because this representing minimum force, because this representing minimum force, it means I must require sixth position for making this force, right? So 1 plus 5 is 6. 6 is not there, so we will represent 7. So this is 7. 7 plus 5 is 12, because we have 3 balls. 2 balls is placed already. So 7 plus 5 is 12. 12 is not there, it means I cannot place all the balls. It means I need to reduce the force now, right? I need to reduce the force because this force is so high that I'm not able to position all the balls. So I need to reduce the, so I need to reduce the forces, need to reduce the forces, right? So if I want to reduce the forces, what we need to change? High need to be changed. So high would now becomes mid minus 1. High should be mid minus 1. So high is mid minus 1 and mid is 5, that would be 4. So low and high is 4 now. So mid would be also 4. So now we will check for 4. The first position would be fixed for one, for the first ball. The second position would be 5, but 5 is not there, so we will put at 7. Now the third ball, there is no place for third ball, right? So again, this 4 value not able to place all the m balls or greater than m balls, right? So again, I need to reduce the forces. So that would be mid minus 1. That would be 3. But if you see, this low becomes greater than this high. That would not be possible, right? Because low started from starting position, high started from the end position. It cannot got overlapped, right? It cannot go out of cannot be greater than low. So now if you see the previous, this 4 cannot be an answer. So previous, what was the answer? What was the our expected answer? That would be 3. So answer would be 3 only, because at position 3 only we have, we got our answer, right? So that is how we will apply the binary search here, definitely, right? So basically, when we change this low and high, so if I can place all the amp balls or greater than amp balls at a specific position, at some specific force, it means I need to check for greater than values. It means I have reduced the search space from starting to that force value, because I have already satisfied till that. So I have not checked. So in this case, we started from 3, and if 3 is satisfied, I don't require to check for 1 and 2 also, right? Right. And if so then the next was 5. So if 5 was not satisfied, it means greater than 5 forces, it will also not satisfy. So it means we have reduced the search space from after 5. So basically we have checked only 3, 4 and 5 out of 1, 2, 3, 4, 5 and 6 and 7. Out of which, out of 1, 2, 3, 4, 5, 6 and 7, we have checked only 3, 4, 5. But this is this very smallest number, right? That was, then we have checked only 3 out of 7. So if you see the bigger large picture, it would be definitely very less small, very small, to check for forces, right? So that's why we use binary search here, right? So let's just implement it, you will understand it better. And that's the same process and same all the things at the previous the yesterday's question, right? So we will just solve this question according to that. The first thing is we need to short it. Why because here you see, the first thing we need to, why we need to short it, because if I check for a specific force, when I do position 1 plus 2, which is 3, so if I don't short it, how will I know that this force is the same force is if how will I know that the next specific position is our required position after this, right? So we need to definitely short it to understand that, because if you randomly see this, suppose they here it becomes 3, then 4, then 2, so how will you decide? But 1 plus 2 is 3, so you need to if you want 3, you need to check in all over the positions, right? Because this 3 can be at any position, right? For now this is at 4, suppose this is 4 at and 3, right? So the next position is 4, but you want 3, and 3 exists in third position. So if you don't short it, you will not get it, right? So that's when you need to short it for sure. So we will just short the positions, short the positions, and then what the range. So what the low values? Low can be 1, and what would be the high value? That would be, what would be the high value? That would be max value. The search space will be max value position minus 1. So max value would be this position I, this position, and minus 1. That's the last value, max position minus 1. Yes. And now we will apply binary search on this, low greater than equals to high, right? Now mid value. So what would be the mid value? High minus low by 2, right? That would be the high minus low value. This is the mid value, right? Now for we need to check for this position, this mid value. So this mid is, of course, this mid is the force. This mid is the force, because this is representing force. This is representing force, right? This is representing force. So this will be mid, and this is the amboss which we need to require to place, right? So if we got m place, so we will check this, right? So let's check, and we will start position. Okay, one thing I will tell you, that you must pass by reference, not pass by value, because I've already told in many videos that uh, if you pass it by values, they create another copy, right? So that takes an extra time, complexity, and space also. If you pass it by reference, it pass the same, it just takes the memory reference, uh, it don't create another copy, right? So always try to pass it by reference, right? If you don't want to change this position later on in this your in your code, so always pass it by reference if you don't want to change the position value. So this is mid, and this is m. Now the thing is, what I need to do the I need to try to place the at I try to place according to this force value, according to the force value. This is the force value, right? Let's make another variable, right? This is the force I need to maintain for the amp positions, right? So the first value would be, we will iterate in the array of positions, right? So the first value would be at position 1. The first ball would be must be placed at position 1. So if I placed first position at position 0, so I need to start from 1, right? Also I need to calculate the number of balls I can place, right? The second thing, I need to maintain the previous position. The right now it is 0. So what I will check that the current position I minus the previous position which I have taken, which is previous, must be greater than this required force, right? because this is the minimum force we want. And if both of the positions, uh, because the force, the what is the magnetic force here, mod x minus 1, right? And we have already shorted it, so I don't need to take absolute value. So the position I minus position previous should must be greater than equals to force. And if it is, then we will increment my count of balls, right? And count of CNT should be start from 1, because we have already placed one ball at position 0, right? So it should be 1. So if this satisfied, we will increment our counter, right? And now the previous would be at I, because we have placed the ball at I now, right? And just we will check that whether this count is greater than equals to m or not. Just simple thing. Why we are not checking that whether, if it is less condition, if it is less, then this previous will not be touched, right? If it is less, then previous will not be touched. So we'll check for further values, position I, further positions I, and previous would be same. That why this previous is needed here, right? Now we will return the CNT greater than m. What it will represent? It is representing uh, true or false, right? If CNT is greater than equals to m, so you can take it as bool also, right? uh, Instead of int, you can take it as bool also, because int takes and bool takes only one, right? So you can take it as bool, because we are returning ultimately true and false also, right? So you just need to check that whether my count is greater than the m balls. What does it mean? It means I can place greater than equals to m balls, so we will return true, otherwise we will return false. If this condition satisfied, it means I have my balls which is greater than the required balls, I can place the balls. It means I this force, this mid force can be our answer, can be our answer. So basically what we do, just we will just store in my answer and check for higher forces, because ultimately we need to find maximum. Previously it was high mid minus 1, because we want minimum, but here we want maximum value, maximum forces. So we will check for maximum forces. And because answer had mid, because this can also be possible if no answer is possible. So, and we will check for further. And if this condition not satisfied, it means we can't place all the balls, and can't place minimum m balls. So just we will just reduce the force, so that I can placed all the balls, right? And at last I will return answer simply, right? So this is how we will solve the question. Let's try to run this. uh, so positions dot size, right? Let's run this. Compilation, no compilation error. Let's submit it. Yeah, we have successfully passed all the cases, right? So if you see one thing here, just try to understand, makes understand some beginners that in some codes you don't see this answer, they just return this high value, right? They just return this high value, because this will also work. They just return this high value to and that would where mostly guys get confused, because why would we return high value? So basically if you see here, this high, if you don't see this, if you don't store this answer, this low becomes mid plus 1, this low becomes mid plus 1. But this high value would be at the low position definitely. Why I'm saying that? If you see in this case, uh, this position, right? The previous was the previous was so how can I say? So okay, let's analyze again, right? So the first was 1, and the last was 6, right? Right. And we have taken mid value, which is at 3, right? So for 3 satisfied this positions, right? I told you that 3 satisfied this position, that 1, 4 and then 7. So if 3 satisfied, I need to increase low by mid plus 1. That would be at 4, right? That would be at 4. So 4 plus 6 is 10, and that would be 5. So 5 will not satisfy because 1 plus 5 6, which is not available, then 7. So we are not able to place all the balls. So that would be high mid minus 1. That would be 4, right? Now if you see, low is at 4 and high is at also 4. When you check this mid value 4, when you check this mid value 4, this 4 would be at 1 plus 4, which is 5, so 7. So this not satisfied, it means we need to reduce the search space. So if you reduce the search space, this high would be at mid minus 1. So if you do this value would be mid minus 1, that becomes 3, right? That would become 3. So if you see this, that would become 3. So this while loop will end because low is greater than high, right? But if you see, we already got an answer. This high value is matching with answer. Is high value is matching with our answer. It means that's why when you got when this while loop, when this while loop end, this high value would be at the position of an answer, at the position of an answer. Because if you see here, the position is at answer, because that shrinks, because the search space is shrinking. Search space is shrinking to the specific answer only, right? Search space is shrinking to the specific answer, right? That's why this high value would be at answer. That's why people mostly write this high or low according to these conditions. If so, mostly if you can if you note if you basically what we need to do, if this low is changing to mid plus 1, basically people answer return high. That's the main reason people return high or low according to this check, right? That's not a rocket science, that's just a observation or logical thing. So basically I told you just to that you don't get confused by seeing other codes, right? So that's the motto of this example. So you can either send it answered or you can send it at high. That's the whole logic. So this, thank you so much. Okay, time complexity, right? Time complexity would be, of course, we are shorting it position. That would be O of n log n. N is the size of position array, plus we are we are applying binary search on forces that could go maximum of position and minus 1. So that would be O of log of take at m, which is max value. And also for each forces, for each force I need to iterate in whole position check value. So that would be n. So n into log of m. So this is would be the this would be the time complexity, and the space complexity would be, okay, and where n is the size of position array, position array, and m is the max force can occur, right, in position, right? That's the that would the that would be, okay, okay, right, that would be the spaces, right? I understand that, right? M is the max force. Again, M is the max force, right? Right. And the space complexity would be, so if you see, we haven't taken any space, right? We haven't taken any space. Although this short takes O of n in other languages, but in C++ it takes only O of 1. So basically we have O of 1, right? So this is the time and space complexity. Hope you understand it. Thank you so much. Bye bye.